This question came in from a student, and I want to walk through with you how you could do this calculation with a scientific calculator. Now, with other technology, such as a particular computer program or even a graphing calculator, you could get a precise answer, but we could use our scientific calculator to estimate where this problem asks us to go to, which is 2 decimal places. Let me walk you through this problem. Here's an important piece that you should certainly be able to follow, even if you aren't able to use the scientific calculator to get the final answer, which is finding I. Then at a minimum, you should be able to do this. Number one, write the formula. So I'm going to write down these steps. Here's step one, write the formula. Step two, write in what each value in the formula can be replaced with. Now we're given the future value of $4,834. We're given a payment amount of $500. We're given the number of payments is 8. And we don't know what the interest rate is per period yet. But that's the second step, is to write out those values, pulling it. You could even see that in the problem, they've done that for you here. So we could call that our step number 2. But in your paper, you would want to write the formula and then write what each of these values is being replaced with. The third step is where we're going to fill in any of the values we know. You can maybe follow this color coding that I have. Let me walk you through that color coding. I have, for the future value, I've highlighted that pink, $4,834. The payment amount is green, $500. And then the N, I didn't replace that one, but the N we could replace with 8. And then we see that the only value left, the only variable left, is the I, the interest rate. So it would look like this, and pardon me for not putting that 8 in there. We'd have it something like this. Here's the equation. Now, if I divide both sides by 500, that's what I'm doing here in the second line, then I'm going to get 9.668. That's not a decimal approximation. That's 4,834 divided by 500 gives us this terminating decimal, 9.668. Now from here, we could use a guess and check process with our scientific calculator. Again, with other technology, you could get a graph and get a more precise answer without guess and check, but this guess and check method is quite efficient. It's not that much of a challenge to do this. So here's how I'm going to try this. I could start with an interest rate of 1%, and that's what I have in this chart. I'm guessing at an I. I'm going to start with a 4%. And I'm going to look to see whether this result I get is smaller or greater than this 9.668. Do you see that that's what I'm trying to get here in this column? This column I'm going for, I'm going to keep plugging in a different I until I get 9.668. When I put the 4/100ths, it's 0.04 in for I. Here's how I do that on my calculator, by the way. 1.04, because 1 plus 4/100ths is 1.04. And then I raise that to the 8th power. On your calculator, it might be this caret 8. And then I'm going to get a value for that. 1.1 and 4/100, so 1.04 raised to this caret bar, raised to the 8th power. Or if you have another button you use on your calculator to raise to an exponent of 8, you could apply that. and then equals. Next, I'm going to subtract 1. And then last, I'm going to divide by whatever the I is. Here we are with the 400ths again that I had here. So divide by that again. When I do that on my calculator, I get 9.214, and I can see that that's a little bit smaller than the 9.668. So I'm going to try something a little bigger for I. I'm going to try the 5 100ths. When I put the 5 100ths in, the result I got was 9.549. Again, let me walk you through the calculator. What I did to get that 9.549 is 1.05 caret, so raised to the 8th power, equals. And then I did minus 1, and then I divided by 0.05. I got 9.549 with that process, so I need to go a little bit higher. So I tried the 6 100ths. Notice what a big jump I get, 16.67. So I know that the answer is going to be between 5 and 600ths. And I can see that it's much closer to 500ths than it is 600ths. So next I'm going to just start trying some additional numbers. You know, you could start with 0.051 and then 0.052 and so on. I jumped to midway between the 5 and the 6 and did 0.055. And notice I'm way off still. I'm 9.722. So I come down a little bit because what am I shooting for? I'm shooting for 9.668. So this 9.722 is too big. Try a 0.054, and I'm getting closer, so I know I'm on the right track, so I'm going to keep going lower. When I put the 0.053 in, I got 9.652. 0.052, I got 9.618, and voila, I can see that I'm actually going to be somewhere. Oh, actually, I didn't need to do that 0.052, did I? I already circled this. I could see that the 9.668 is somewhere in here, right in between the 687 and 652. So I could say it's 0.053 something. Let's just say 5. All I need to do is round to 2 decimal places. So I could really comfortably say 0.05 is going to work. I know this process isn't maybe something you're familiar with using. It's a guess and check process that you can sometimes use rather than having a financial calculator. And by the way, those of you who go into a finance type of a career, there is a calculator that will do this for you also. You could also graph this equation. When we put the 8 in, we could graph this and get an estimate that way also. But without a graphing calculator, this guess and check on a scientific calculator works pretty easily. Well, I hope that you found this helpful. If you do have any further questions about it, please don't hesitate to reach out to me.